Welcome Algebra 1 students to another Regents review video. This is the June 2016 Regents examination for Algebra 1 Common Core. These are going to be the solutions for parts 2 through 4. These are the open-ended response questions that requires your work to be shown. Before we begin, please do not use this video for cheating purposes. Actually do the problems first, then come back here to check your answer solutions. But if you are here to check, I welcome you. Hit that subscribe button down below and make sure that you visit my website at www.nysmathregentsprep.com. And just a quick reminder that I use a TI Inspire CX for all of my Algebra 1 videos. Without further ado, let's begin. We're going to jump right to number 25, and we're going to do the part 2s today. Here we go. So 25 says, given that f of x is equal to 2x plus 1, find g of x if g of x equals 2 times f of x squared minus 1. So what we need to do is we need to say, all right, g of x, right? That's equal to 2. Now, f of x, they tell you that f of x is 2x plus 1. So that is 2x plus 1 quantity squared minus 1. I just plug that in, okay? Let's continue to simplify. So we get g of x is equal to 2 times 2x plus 1, 2x plus 1, because I can now write it twice because that's a square, minus 1. So now, if I continue to simplify, I can now FOIL these, first, outer, inner, last. So g of x is equal to 2 times, this is going to be 4x squared plus 4x plus 1 minus 1, right? Now from here, I could distribute that too. So I now get g of x is equal to 8x squared plus 8x plus 2 minus 1. At the very end, you get g of x is equal to 8x squared plus 8x plus 1. And ladies and gentlemen, that is your answer. G of x is equal to 8x squared plus 8x plus 1. Let me just write it nice and big for you to see. That is your answer to question number 25. All right, and you just solve that just by basically plugging it in and solving. That's all there is to it. Not too bad. 26. Determine if the product of 3 radical 2 and 8 radical 18 is rational or irrational. Explain your answers. So, the product means multiplication. So, 3 radical 2 times 8 radical 18, right? Well, 3 times 8 gives you 24. Radical 2 times radical 18 is the square root of 36. Well, what is the square root of 36? That's going to be 6. So this is, this is really 24 times 6, which is equal to 144. Is 144 rational? And yes, it is. So we're going to say rational because 144, the number 144, terminates and can be expressed as a ratio of 2 integers. Such as 144 over 1. That's the ratio of 2 integers. But if you just say that 144 terminates, that is the definition of a rational number, you are good to go. All right, moving on to question 27. On the set of axes below, draw the graph of y equals x squared minus 4x minus 1. So go right to your graphing calculator, and you're going to graph it right now. So x squared minus 4x minus 1. All right, we get that. Control T. Find the turning point. The turning point is at 2, -5 because the same y values are above and below it. So this is your turning point. So now all you need to do is just create a table of values. So x and y. I need to draw a line here because my lines are disgusting. So I'm going to go from -1 to 5. So -1, 0, 1, 2, 3, 4, 5. Then we get 4, -1, -4, -5, -4, -1, 4. These are the values that you get from your table of values off the calculator. Now we're just going to graph it. So we get -1, 4, 0, -1, 1, -4, 2, -5, 3, -4, 4, -1, and 5, 4. Ladies and gentlemen, this is your quadratic right here. Hopefully I could draw this neatly, and I think I can. There we go. And this is y is equal to x squared minus 4x minus 1. All right, and that's how you graph it. Now, the follow-up question is state the equation of the axis of symmetry. Well, you could do this two ways. Either you could do it graphically or you could do it algebraically. I'm going to do it both ways for you. The axis of symmetry formula is negative b over 2a, right? So your b value is negative 4, your a value is 1. So just plug it in. And that's going to be negative 4 over 2 times 1. That's just positive 4 over 2, which is 2. So your equation of the axis of symmetry is x equals 2. That's shown it algebraically, but graphically, since you do have a graph, you could just say, look at my graph page. And this, ladies and gentlemen, is symmetrical, meaning that it splits it in half. So this is x is equal to 2, the vertical line x equals 2. And that is the answer. All right, moving on to question 28. Amy solved the equation 2x squared plus 5x minus 42 equals 0. She stated that the solutions to the equation were 7 halves and negative 6. Do you agree with Amy's solution? Okay, I'm going to do this by the quadratic formula because completing the square is definitely more complex. So I'm going to do the quadratic formula. So x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. The reason why I'm doing the quadratic formula is you can't solve this by simple factoring of what adds to the middle term and multiplies to give you the constant term, because this number 2, that's not the number 1. So we are forced to use maybe the quadratic formula. So we get negative 5 plus minus the square root of 5 squared minus 4 times 2 times negative 42 all over 2 times 2. This will then give you x is equal to negative 5 plus minus the square root. Well, when you type this into your calculator, you get 361 over 4. That will give you negative 5 plus minus 19 all over 4. Now what this does is it then splits into two numbers. We split it into x is equal to negative 5 plus 19 over 4, and x is equal to negative 5 minus 19 over 4, right? So we get x is equal to, well, let's see, 19. This will give us 14 over 4, which is 7 halves, so that's good. And over here we get, let's see, negative 19. That gives us negative 24 over 4. X is equal to negative 6. So that is true. And she said that those are the roots. Yeah. Do you agree with Amy's solutions? Absolutely I do, because Amy's a smart girl. So we're going to say yes, I agree, because the quadratic formula produced the same solutions. And that is it. We are done. Okay, moving on. 29. Sue and Kathy were doing their algebra homework. They were asked to write the equation of the line that passes through the points negative 3, 4, and 6, 1. Sue wrote y minus 4 equals negative 1/3 times x plus 3, and Kathy wrote y equals negative 1/3 x plus 3. Justify why both students are correct. So, ladies and gentlemen, this might be a form that you might not be familiar with. This is called point-slope form. And if you don't know it, don't worry. You probably didn't learn it this year. This is really taught in geometry, which you'll see next year. But we'll just talk about it now. So Sue wrote this equation. Y minus 4 equals negative 1/3 times x plus 3. What if we make Sue's function look like this? We could do that by just taking that negative 1/3 and distributing inwards. So we get y minus 4 equals negative 1/3 x minus 1, because negative 1/3 times 3 is just negative 1. Now I could add the 4 on both sides, and you get y is equal to negative 1/3 x plus 3. Look at that. your slope is in fact negative 1/3, and your y-intercept is the point 0, 3. Now, if you look at Kathy's function, Kathy said the same. Look at that; it's the same freaking formula, or the same line, same equation. That's it. So great. So this, which is Kathy's function, is the same thing. It's the slope of negative 1/3 and a y-intercept of 3. So it says justify why both students are correct. So what I'm going to say is I'm going to say that both students are correct because they are the same line. Same line. Sue just decided to use point slope form while Kathy used slope intercept form. The vocabulary in this is quite important. If you know slope intercept is y equals mx plus b, and you know that point slope form is y minus y1 equals m times x minus x1, you are good to go. Now, both equations pass through the points negative 3, 4, and 6, 1. Ladies and gentlemen, that is your justification, and that's really all you need to write for your justification. All right, and that is the answer. All right, moving along to question number 30. During a recent snowstorm in Red Hook, New York, Jamie noticed that there were 4 inches of snow on the ground at 3 p.m. and there were 6 inches of snow on the ground at 7 p.m. If she were to graph these data, what does the slope of the line connecting these 2 points represent in the context of this problem? So first and foremost, you actually have to find the slope. So slope, remember, is y2 minus y1 over x2 minus x1, which is just the same thing as saying delta y over delta x. Remember that delta means change in y over the change in x. So to find this, we just take the 6 inches of snow and the 4 inches of snow. So 6 inches of snow minus 4 inches of snow divided by the time that went by. Well, how many hours is between 3 and 7? 3 to 4, 4 to 5, 5 to 6, 6 to 7. That's a total of 4 hours that went by. So this is 6 minus 4 inches over 4 hours. That is 2 inches over 4 hours. That actually means 1 inch over 2 hours. So that means that in 2 hours, 1 inch of snow has fallen. So here is your answer. The answer is, in the context of this problem, oops, forgot the T. In the context of this problem, the slope of the line represents the rate of snow falling per hour. The rate of 1 inch of snow per 2 hours shows it is snowing at an average rate of 1/2 of an inch per hour. Ka-ching! That's all you need to do. That is your answer. That's how you explain it. That's how you justify it. And that's about it. That's how the slope is in terms of the context of the problem. All right, moving on to question 31. All right, the formula for the sum of the degree measures of the interior angles of a polygon is s equals 180 times n minus 2. Solve for n in terms of the number of sides of the polygon in terms of s. So we have s equals 180 times n minus 2. You're solving for n. So the first thing that I want to do is I want to divide by 180 on both sides. So we get s over 180 is equal to n minus 2. Now you're just going to add the 2 on both sides, and we get n is equal to s over 180 plus 2. Ladies and gentlemen, that is your answer. Now, just for those people who did it differently, if you wrote n equals, oops, that looks like an H. If you wrote n equals s plus 360 over 180, you would also be correct. So either one of those two answers is perfectly fine to get this question right. All right, question 32. In the diagram below, f of x equals x to the third plus 2x squared is graphed. Also graphed is g of x, the result of a translation of f of x. So it looks like to me personally that this is f of x. It looks like it's being shifted down by, what is that, 4 units? Okay, just keep that in the back of your brain for a moment. Determine an equation of g of x. Explain your reasoning. Bingo. So determine the equation of this new graph. Well, if f of x is x to the third plus 2x squared, g of x is just going to be equaling x to the third plus 2x squared minus 4, because this shows the vertical shift down by 2 units. So we're going to say that f of x has a y-intercept of 0. And g of x has a y-intercept of negative 4. This shows a vertical shift down 4 units. And that's it. Cool. All right, that's how you do that question. Moving on to question number, let me try to fit this nicely. Okay, that's good. All right. Moving on to question number 33. All right. 33. The height, these are the part 3s. Here we go. The height h in feet of an object dropped from the top of a building after t seconds is given by h of t equals negative 16t squared plus 144. How many feet did the object fall between 1 and 2 seconds after it was dropped? So in other words, you're just going to plug in the number 1 and the number 2 because this is a height function. They tell you the height if you plug in the numbers. So what I'm going to do is I'm going to take h of 1. I'm going to plug in 1. We get negative 16 times 1 squared plus 144. So that's going to equal 128. Now, h of 2 is going to be negative 16 times 2 squared plus 144, and we get 80. So how many feet did the object fall? We just take 128 feet minus 80 feet, and your answer is 48 feet. And that's the amount of feet that the object fell by between 1 and 2 seconds. Okay? Now the follow-up question says, determine algebraically how many seconds it will take for the object to reach the ground. So all we need to do is we need to take negative 16t squared plus 144, and we need to set it equal to 0, because the height, when the object reaches the ground, the height is at 0. So since this is a height function, set it equal to 0 and solve for the value of h. Or, sorry, in this case, t, because they're asking for seconds. So we now need to factor. Take out a negative 16, because 16 could go into 16 and 144. Take out a negative 16, you're left with t squared minus 9 equals 0. This could factor by dots. So you get negative 16, the carries along for the ride. You get t plus 3, t minus 3, and you set it equal to the number 0. You t-bar, that negative 16 cancels. You get t equals negative 3, and t is equal to positive 3. You cannot have negative seconds, so you're forced to go with the 3 seconds. So your answer for this is 3 seconds went by for the object to finally reach the ground. And that's it. All right. Moving on to question number 34. The sum of two numbers, x and y, is more than 8. Okay, so the sum of x and okay, so they're asking me really to set up a systems of equations. So x plus y is more than 8. Okay, so that's greater than 8. And when you double x, so 2 times x, and add it to y, the sum is less than 14. All right, ladies and gentlemen, these are my two inequalities that I need to graph on the set of axes below. So, here we go. We're going to graph these. I'm going to graph my blue function. So, the blue function has a y-intercept of 8. So, I'm going to go ahead and zoom this in a little bit. So, we get 1, 2, 3, 4, 5, 6, 7, 8, like that. And we're going down 1 to the right 1 because this is the same thing as saying y is greater than negative x plus 8. So it's a downward slope. So plot all of these points. And we do it in reverse. Now, since this is a greater than sign and there's no equal sign underneath it, this is going to be a dotted line like this. It's going to be a dotted line. Now, the same thing goes for over here for the red. We just graph it. Now, this is y is less than negative 2x plus 14. So you're going to go up to 14, and you're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and you keep on going. Like that. Now, all we're going to do is we're just going to have a dotted line again, and we draw... Whoopsies. And we draw those lines right here. So, now we need to talk about the shading for a second. The blue is shaded above because it is greater than. So it is definitely shaded above in this direction. The red function is less than, so it is shading downward this way. So your solution set is right here. Right where they cross. So that's the solution set. And that's how you graph it. Done. Now, there is a follow-up question. And it says here. Kai says that the point 6, 2 is a solution to the system. Determine if he is correct and explain your reasoning. So 6, 2. 1, 2, 3, 4, 5, 6. Okay, so Kai made a common mistake. He picked the point where the lines supposedly cross. But again, these are dotted lines. So that's not a solution because the dotted line suggests that that point is not a part of the solution. So we're going to say that Kai is wrong because the point 6, 2 does not satisfy the inequalities. You could also say it is not in the solution set. Either one of those answers is fine, and that will give you full credit. All right, moving on. 35. Moving on to 35 here. Alrighty. It says here, an airplane leaves New York City and heads towards Los Angeles. As it climbs, the plane gradually increases its speed until it reaches cruising altitude, at which time it maintains a constant speed for several hours as long as it stays at cruising altitude. After flying for 32 minutes, the plane reaches a cruising altitude and has flown 192 miles. After flying for a total of 92 minutes, the plane has flown a total of 762 miles. Determine the speed of the plane at cruising altitude in miles per minute. So, I'm going to draw a picture to show how this works. Alright, so bear with me as I set this up for you. Okay, so here is... I'm going to zoom this out. Hold on a second. Alright, so here is the takeoff. This is the cruising altitude that the plane is going. And actually, if I search up plane in here. I think I could actually... Let's see if I have a picture here. Airplane, 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 airplane. Airplane. Ooh, nice. We got an airplane. So here's an airplane. Okay. And it takes off. I'm going to flip this. So it's taking off. It's going up, but up, but up, but up, but up. And it's staying at a cruising altitude. So the plane, what's happening here is that this plane is at the airport right now. And after flying for 32 minutes, it starts to go... All right, so it's going up. 32 minutes pass by. This aircraft has flown 192 miles right at this point in 32 minutes. Okay? Then all of a sudden, the plane is all the way over here, and this plane traveled a total of 762 miles in 92 minutes. But you need to be careful. It says that it flew 762 miles from the starting position. So that means that the plane from here all the way to over here flew 762 miles. Now we need to find the speed at the cruising altitude. Well, you should know the formula. Speed equals the change in distance over the change in time. Speed equals the change in the distance over the change in the time. So, the change in distance is between 762 and 192. So, we have speed equals 762 minus 192 all over the time. Well, 92 minutes minus 32 minutes. 92 minutes minus 32 minutes. So this means that the aircraft flew 570 miles in 60 minutes. However, ladies and gentlemen, what's nice about this is how many minutes are in an hour. There are 60 minutes in an hour. What's nice about this question is we could just divide these numbers and it will convert it to hours easily. So we take 570 and divide it by 60 minutes. We get 19 halves, which is equivalent to 9.5. So this plane, the speed of the plane is 9.5 miles per hour, because it's saying hours, right? No, I'm sorry. Miles per minute. My apologies. Miles per minute. I don't know why I was talking about hours. I think that I thought that it said hours, but it's 9.5 miles per minute. That's it right there. Okay? And that is how you do that one. Then the follow-up question says, write an equation to represent the number of miles the plane has flown, y, during x minutes at cruising altitude only. So, this is interesting. This is a horizontal line. Cruising altitude is a horizontal line because, cruising altitude, you're saying straight. You're not going up or down. So the equation is y is equal to 9.5. That 9.5 represents the amount of miles in X amount of minutes at cruising altitude. Ladies and gentlemen, this is your equation of the line. Then another follow-up question. Assuming that the plane maintains its speed at cruising altitude, determine the total number of miles the plane has flown 2 hours into the flight. So remember that this is in minutes, miles per minute. This is why I was thinking of hours, because I knew what was coming. So in 2 hours, 2 hours is equivalent to 120 minutes. Because if you take 60 minutes and you multiply it by 2 hours, that gives you the total amount of minutes. So we get y is equal to 9.5x, which is right here, plus an additional 192 miles. Now, what just happened? Well, let me explain. y is equal to 9.5x. That is the cruising altitude function. They're talking about the total number of miles. You need to take into account that the plane flew at a distance of 192 miles to begin with. So as it was taking off to reach its cruising altitude, it traveled 192 miles. So we need to add that into the equation. Now, we need to figure out so we need to figure out 120 minutes. So y is equal to 9.5 times 120 plus 192. Plug it into your calculator, you get 1,028 miles. And that, ladies and gentlemen, is your answer to that question. Definitely an interesting one, that's for sure. All right, we're almost done with this. Almost done. 36. On the set of axes below, graph these things. So let's talk about the first one for a moment here. This is a line, g of x. It has a slope of 1/2, and it has a y-intercept of 0, 1. This is a piecewise function. This is a piecewise function, and this top one that you see over here, this has a slope of 2. And this is a parabola, so we're going to talk about that in a moment here. So let's first graph this line. So it has a y-intercept of 0, 1, and you're going up 1 to the right 2, up 1 to the right 2, and you keep on going, and you go in the reverse direction as well. All right. So from here, you just go ahead and graph that line. And now you could label it as g of x is equal to 1/2 x plus 1. Okay? So now let's go ahead and graph the piecewise function. The piecewise function, it's really the point of jump discontinuity or jump that's happening is at -1. So the line has a slope of 2, and it stops at -1. So that actually stops right here. And the reason why is that this has a y-intercept of 1. Well, you need to take into account, you can't put it over here because it has to be less than -1. Or, sorry, less than or equal to -1. So we can't include this, but we do know that go down 2 and to the left 1 has that slope. And I'm going to erase that point that I just drew over here. We can't include that. Can't include it. But what we can do is we can make a line extending from this point downwards. Now your parabola, now just take my word for it because I'm not going to be graphing this on the calculator, but the parabola starts at this point right here with an open circle. Its vertex is at +2, the point 0, 2, and it goes down this way to -2, 3, -7. Let's see. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, that is your second half of the piecewise function, which is your parabola, which is that function right there. Now, this point right there, that is the intersection, just in case you're curious. And this orange function, make sure that you label it. This is f of x is equal to the piecewise function of 2x plus 1 for x is less than or equal to -1, and this is 2 minus x squared, where x is greater than -1. All right, so now from here, that's it. And it says a follow-up question: how many values of x satisfy this equation? Explain your answer using evidence from your graph. Well, there's only one intersection point. That's it. So we're going to say one value because the functions, which are f of x and g of x, intersect each other at only one point on the graph. And that's it. You're done. Because it clearly shows only one point on the graph. Pretty simple, right? All right, so that's the answer to question number 36. The final question on the Regents examination. 37. Franco and Carl went to a bakery to buy desserts. Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. Carl bought 2 packages of cupcakes and 4 packages of brownies for $24. Let X equal the price of 1 package of cupcakes and let Y equal the price of 1 package of brownies. Write a system of equations that describe the given situation. So let's talk about this for a second. Let's talk about all right, I'm going to put this as F and C because F for Franco, C for Carl. So f of x, which is Franco's function, that is going to be 3x plus 2y equals 19. And I want to make this clear. X is equal to the cupcake and y is equal to the brownie. Okay? So that's Franco's function, and Carl is going to be C of x is going to be 2x plus 4y is equal to 24. So this, ladies and gentlemen, over here is Carl's function. And that's it. Okay, good. So we got those 2 equations. Now it says on the set of axes below, graph the systems of equations. So on the left-hand side, I'm going to type it out. On the left-hand side, this is the number of brownies. It would be in your best interest to actually label this. You don't necessarily have to, but it's just to get in a good habit. And down here, this is the number of cupcakes. Okay. Number of brownies, number of cupcakes. I'm going to make that font a little bit smaller. Okay, so that's the number of brownies and the number of cupcakes. So, God, I am so freaking hungry with these. Okay, so all you're going to do is you're going to graph Franco's function first. Well, Franco's function in simplified terms is 2y is equal to negative 3x plus 19, which is equivalent to y is equal to negative 3 halves x plus 19 halves. Well, 19 halves is in the middle of the axes. So 19 halves is equivalent to, give me just 1 second, 19 halves is 9.5. So let's see how many boxes there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this obviously is going to be 9.5 right there. All right, and we're going to go down 3 boxes to the right 2. Right? Or, sorry, down, all right, so down 1.5. So down 1.5-ish to the right by 1. Down 1.5 to the right by 1. Down 1.5 to the right by 1. Down 1.5 to the right by 1, and you just keep on repeating that process. Unfortunately, you are in the middle of the graph here of the axes. So from here, you're just going to graph that line, right? Like that. Okay? So that is Franco's function. Now we're going to graph Carl's function, and Carl's function is 4y equals negative 2 x plus 24, that is y is equal to negative a half x plus 6. So go to 6, and we're going to graph his function. So 1, 2, 3, 4, 5, 6. We're going down 1 to the right 2, 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 and we graph that little guy right there. Now, of course, label. That's in your best interest to label. So this red one is 2x plus 4y equals 24. And this is 3x plus 2y is equal to 19. And that's it. So graph it and you're done. One last question. Determine the exact cost of 1 package of cupcakes and the exact cost of 1 package of brownies in dollars and cents. Justify your solution. So the one thing that you dreaded is you actually have to take their system of equations and you got to solve for both of them by hand. So, of course, you have to do it. So, from here, I'm gonna solve for x. Actually, I'm gonna solve for x first. X is what I say. X was brownies. No, x was cupcakes. So we're gonna solve for the cupcake first. All right. So I'm going to actually get rid of that. I'm gonna multiply the top by -2 because I'm gonna cancel out those y's. I don't want brownies. I want cupcakes right now. So we're gonna distribute by that -2, even though the brownies are so much better than cupcakes. I'm sorry. If you like cupcakes more than brownies, no. Actually, I don't know. If you live in Manhattan, or if you live in the city, or if you're nearby a mall that has Crumb's cupcake store, those big gigantic cupcakes, oh, those are so good. Oh, those are wonderful. What do I get? I usually get like the cupcake that has like it's shaped like a ding dong with the white swirls on it. It is so freaking delicious. I love that cupcake store. But I heard it filed bankruptcy like last year, like 2016 or something, or 2015, I should say. So I'm not so sure if it is still in business, but I think it is in Manhattan. Okay, enough of my chit chat. Cancel out those y's, so we get -4x is equal to -14. Divide by -4 on both sides. Oops. Crap. Divide by -4 on both sides, and we get x is equal to 7/2, which is equal to $3.50. Now what we're going to do is we're going to solve for cupcakes. No, I'm sorry, brownies. So we're going to take the $3.50 and we're going to put it back into one of these functions. I like the top one because the top one seems easier to me because there are smaller numbers. So we're going to solve for the brownie. Try Brownie Brittle if you haven't done so already. It's sold at Costco or BJ's. I promise you, you will never eat another brownie again. Brownie Brittle is that good. I am so freaking hungry right now. It's so... There's too much food. We're talking about airplanes, then we're talking about food, then we're talking about... No. I'm sorry. I'm hungry. So 3 times 7/2 plus 2y is equal to 19. So this becomes 21/2 plus 2y equals 19. Subtract the 21/2. Subtract the 21/2. So we get 2y is equal to 17/2. When you plug that into your calculator, divide by 2, and you get y is equal to 17/4, which that is equal to $4.25. So ladies and gentlemen, your final answer, to write it down, is the cupcake. The cupcake is $3.50. And the brownie is $4.25. And that is the answer to this question. Let me move this because my head is probably in the way right now. Let me move it up here. There we go. Cupcake is $3.50, and the brownie is $4.25. And that is the conclusion of this Regents Review video. I hope that it helped. Please make sure that you hit that subscribe button down below, and make sure that you visit my website at www.nysmathreadersprep.com. And that has more content in Algebra 1 and future high school math subjects that you will be in taking the Regents exams next year and the year after. And I hope to see you soon.